Great, thank you. Hi, everybody. We want to really thank you very much for joining us today. My name is Elaine Rayborn. I'm from Sandia National Laboratories, and I'm joined by a really fantastic team today. Reed Malevich, David Moulton, Miranda Munt, Todd Munson, David Rogers, Ben Sims, Jim Willenbring, Greg Watson, and Eureka Yang. And our session is called What Can Be Learned from Applying Team of Teams Principles to PETSc, Trilinos, xSDK, and E4S. And so we want to really thank you all for joining us. This is going to be a really great session. All right, so as you can see, we've got a pretty packed schedule. So for the next 90 minutes, what we'll be doing is discussing a little bit about Team of Teams, the introduction motivation for our work, and then followed by Todd and Jim and Eureka will be talking about the different teams, and then we will follow up with some commentaries on how we can apply the lens of Team of Teams to the specific teams that we're going to be discussing today as case studies. And then we have about half an hour planned for audience Q&A, and we're really hoping that you'll get involved and put some questions in the chat for us. So Miranda Munt will be monitoring our chat and taking note of the questions as they come in. And so I think depending on the time we have, Miranda, since it's so tight, what we may want to do is save most of the questions for the Q&A period. And then at the end, we'll all conclude. So thanks everyone for participating. So as I said, this session is about Team of Teams, and those of you that have joined us you may have come to this session because you participated in some previous sessions that we've had at different annual meetings about Team of Teams. So we started presenting this work in 2019, talking about the ECP project as a team of teams. So I think a lot of times we have a tendency to think of ourselves as a one large team. And as you probably have heard Doug Cothe mention and others, many times, we're a collection of 1,000 researchers. We're across several projects, and it's a really complicated project. The ECP is a complicated project with a very important mission. And so early in 2019, David Moulton and I and others came across this book by Stanley McChrystal, retired general, on Team of Teams. And the idea behind Team of Teams is that sometimes it's really valuable to think about a large organization, not as necessarily hierarchical, or if we can, to try to structure them as networked smaller teams so that we can really leverage the agility of small teams, the productivity of small teams, and also that accelerated communication that comes from different nodes in a large network. And so some of the key ingredients to Team of Teams that you'll hear us mention for the rest of the 90-minute period are that Teams of Teams share certain things in common. And so one is definitely a type of shared consciousness or an aligning narrative, a type of mission statement or narrative that really unifies the efforts of the teams in the particular network. They also exhibit empowered execution, and that is a certain degree of interdependency and autonomy at the level where they feel that they can execute without too often having to go up the chain, as you can imagine, in a hierarchical organization to get quote unquote permission for taking certain actions. And then another really key ingredient about facilitating a team of teams and the growth of this type of network is to lead as a gardener. And I don't want to say too much about that because I know that the others will be talking about it, but it really involves shifting your focus from the individual moving parts to actually the entire ecosystem. And then another key ingredient of Team of Teams is really having this idea of embedded members or liaisons that are members of more than one team and able to communicate with each other to, in other words, bring back key lessons or what might be happening in certain teams to other teams to really facilitate and accelerate that communication. And so what ECP has done, and you'll see this through the annual meeting, is ECP has done a really good job of providing opportunities for our teams to foster this type of culture in our training and productivity, in our strategies for working remotely, series and panels on performance. We have had many opportunities even throughout the pandemic to foster this type of network and culture, and also to develop the skills and resources that we need to be a fully functioning team of teams. Or have we? And so this is, I think, the point of what we would like to do today is to really question and look at, to what degree is ECP a team of teams? And where are there challenges? And where are there points where we are taking key lessons learned and best practices? And then what can we share with others about the progress that we're making? So with that, I would like to go ahead and invite Todd Munson to take the floor, as you will, and tell us about PETSc. Thank you, Todd.
Hey, thank you, Elaine. So I'm going to just spend a little bit of time talking about PETSc and how we utilize some of the concepts inside of the team of teams. I like to focus here on the fact that we're cultivating a garden. PETSc development is generally described as being more organic, so it's a bottoms-up principle. So sometimes we are the flowers and the fruit-bearing trees, and sometimes we're the worms aerating the soil, and we have to be flexible about where we're at within the things that we're doing within the PETSc Tau project itself. So if you go to the next slide, a very brief overview of the PETSc project is at a high level. We're providing efficient, scalable, and customizable and application-focused linear algebra and nonlinear solvers, integrators, numerical optimization methods, specifically for large-scale scientific applications. We have a very strong emphasis on interoperability and with complementary software. So we integrate software from third parties into the PETSc project and make those available to our users through a common, consistent interface. Some of the key aspects of PETSc is that it really is a global community with many contributors. We have contributors from around the world, from KAUST, from France, from Australia, all over the place, which makes a little bit of the coordination aspects a little bit more difficult given the vast breadth of time zones that we have to deal with. Many of the people really think about themselves, they live in a context of the PETSc software, but they're also working on their own little individual projects and or in projects in very small groups of 2 to 3 people typically. So we do biannual releases. We have had releases every 2 a year. PETSc's been around for about 25 years right now, so there's a lot of culture embedded in the PETSc project and a lot of inertia for maintaining the culture that we have. We have support for many different algorithms and data structures. We have support for all the GPU backends. We do a lot of work on communications, and we are included in the xSDK release, which will be talked about a little bit later. If you go to the next slide. So in the context of ECP, what we've been doing for the ECP particular part of the project, so ECP funds a part of PETSc Tau, not the full breadth of everything we do inside of the PETSc project. The ECP focus is really on the accelerator strategy, and here we want to maintain flexibility and performance. By flexibility, we want to support the tools that the application developers are actually using, and by performance, we want to support all those tools as well as gain performance for them on the actual machines that will be deployed. And we do that by optimizing our kernels and libraries and our communication process. So this means that we have to be a little bit flexible in what we're doing. And so we have people who are specialists in working on the accelerator aspects of the PETSc Tau project. To support this activity, we rely on external contributors as well as those that are directly funded by the project itself. So there are some people who are funded by the project, and then there are other people who are external to the project who also provide critical support for our accelerator strategy. And these are all, and many of the external collaborators are global. So as I said earlier, it's really a global community that we're dealing with in terms of PETSc itself. If you flip to the next slide, in terms of the structure, I like to think about the structure that we have inside of PETSc, the PETSc project, in this sort of eggshell type model. It's not perfect, but it's sort of what we have in terms of the model itself. Everything begins with the individual, and then it goes up to a number of groups that we have. And then there are communities within that are user communities, developer communities, as well as other communities that we have that are working with PETSc Tau or working on development of PETSc Tau, and we all live within an external environment. So if you flip to the next slide, the first things that we need to know about PETSc and how it interacts with Teams is that everything that we do typically begins with the individual. So we have a lot of individuals across the PETSc project. They all have their own needs and wants and desires, and they are typically volunteers. So they're not being paid by Argonne. They're not being paid out of a particular fund from the Department of Energy. So we really have to adapt what we do and what we need to their own particular needs and wants and interests. So typically a project is identified by an individual and they decide, I want to do some particular activity within PETSc Tau, and then there's various structures that we have within the community for managing merge requests and things like that. So all of the individuals are part of the PETSc community, whether they're supported by us financially or not, and they're ultimately responsible for choosing where they want to contribute within the project. We can't force anybody to do it. We have, as I said, it's a very much a volunteer army of developers spread across the world. If you go to the next slide, we also have some small groups within the project, and this is where I like to think about where we're cultivating a garden. If you recall, there's these groups that are sort of connected together, and we have this sort of cohesion. They tend to be focused around common toolkits within the Argonne, within the PETSc project itself, whether it's the integrators or the time steppers or the linear and nonlinear solvers or the accelerator support.
Just wanted to give you a quick 1-minute warning, okay?
1-minute warning. Oh no, it's going way too fast. So I just wanted to say here that we do have groups, and we do have small groups, and we have meetings among the groups. So for example, here is the Argonne group. This is mainly the people that are at Argonne that are funded by the Department of Energy. We have a group meeting, bi-weekly group meeting among the groups so that we can share what's going on and things of that sort. And we also have a consortium of the managers who are managing the individuals in that group to develop more of a shared vision and sort of look at the individual pieces. If you go to the next slide, we also live in the context of a broader community. And within that community, there's the developers, the users, as well as the research community. The developer community, we also we also have structures for communicating among the developers, whether it's via email, Slack, GitHub issues. And we also have a bi-weekly developers forum for all the developers to get together. And usually at the developers forum, we discuss issues that are going on with PETSc, and we also come to consensus or come to some decision on any of the contentious merge requests that we have going on, especially the big merge requests that, there's usually some conflict between groups and that we need to manage and talk through the issues with those big merge requests. So the communication channels among the other communities vary, but they do communicate with each other. We do have people embedded in all of these small little groups across the developer community, at least. And so it sort of mimics the picture that we had before, except our groups are typically a little bit smaller than, and usually consist of 2 to 3 people in each one of the groups. And then if you go to the end, so this is the last slide that I had. We all live in the external environment, which includes the Department of Energy and the world and the countries in which we live. But we all share inside of the PETSc Tau group is we have common interests around a specific software package. And the most important aspects to us are that we are really cultivating a garden here. So it's organic development of the PETSc Tau software. It's not centralized or a top-down development effort. And we all have to be flexible about how we are managing the team, given the fact that many of our contributors are external to us and are really volunteers in this effort to deliver this high quality software to the scientific community. And with that, I will stop. Okay, so you could go to the next slide, I believe.
Great, thank you very much, Todd. Okay, Reed.
Yeah, so I just want to talk a little bit about kind of to add to what Todd just said. So when we're talking about a team of teams here in the ECP, we're thinking in 2 complementary senses. One in which that the ECP itself may be seen as a team of teams because we're bringing together all of these different codes and groups and institutions, and they have to work in a unified way. But in reality, many scientific teams themselves, like software teams, are teams of teams. They're increasingly community driven. They are increasingly multidisciplinary and multi-institutional. And when we think about this, and we think about Todd's point here about a bottom-up organizational structure, we can think about in what ways is a team of teams different from a conventional organizational structure, like as a hybrid organizational structure. So a common form of open source project community structure that we see in the wild is the onion, or it's called a core periphery socio-technical structure. So what happens is you have a core of core developers, and then you have a periphery of people who rely upon the software. And then outside community members who become involved in the project may steadily migrate into the core. And all of this it's a good way of structuring a software project, but all of this implies a singular core team. It implies clear delineations between who is in the core and who is on the periphery. And of course, there's usually a top-down hierarchy of governance from the core out to the periphery. And if we think about how a team of teams is different, we can look at PETSc as an example, right? So PETSc involves many different teams, many different communities, often built bottom up from individuals. And each of these different groups are going to have different needs and different perspectives on the project than what they want to get out of it. And what we see is that by increasing transparency and increasing community engagement, you see how PETSc is sort of moving away from this concept of an encapsulated core team that is, just separate from everything else, and more towards inner team and inner community leadership. Now, with any team of teams, then, as you become more distributed, as it becomes more hybrid, maintaining that mutual awareness and that alignment of goals between all those different stakeholders, that becomes increasingly important in a team of teams environment. And what we see is what Todd alluded to here is that PETSc has many different groups and consortia and forums, and they have all kinds of communication happening over many different modalities, and that this kind of happens organically, right, as a necessity in order to be able to maintain that cohesion and that shared sense of task and purpose. So I think that PETSc in this way really does reflect the team of teams kind of structure that we see oftentimes in community scientific software development that is distinct from other forms of software development that we see in the wild. That would be my commentary.
Thank you very much, Reed. That's great. Appreciate that. So let's go ahead and move to our next topic, which is actually going to be Trilinos. Jim?
Yeah, do you want to advance to yeah, there we go. Perfect. Thank you. So I want to contrast Trilinos with PETSc a little bit. Trilinos and PETSc are both at the kind of individual project level, and both are part of the xSDK, and both are part of E4S as we'll work kind of down this hierarchy or up this hierarchy, if you will, different sizes of teams. But Trilinos is a little bit different. If you're not familiar with Trilinos, it's a collection of reusable scientific software libraries. It began as a linear solver project and a little bit nonlinear solver, and then added some more capabilities over time. The Trilinos community includes a lot of developers, many of whom are also users, and they collaborate with application teams or are embedded on application teams towards a wide variety of objectives. Next slide, please. Trilinos is a little bit unique in that it's comprised of roughly 60 different packages. And this is a fairly loose federation of packages. Many of the packages have package teams associated with them. Some are not as actively developed anymore. At this time, the project's about 20 years old, and maybe the maintenance is shared amongst different contributors to that package at this point. The packages can be grouped into 5 rough product suites, as you can see here also. So that's another pairing of another level of teaming. So if you want to advance to the next slide. Very naturally, if you just look at Trilinos, you see that there's all these different package development teams, these different groups of developers. There's also an infrastructure team, the Trilinos framework team. There's also the Trilinos leadership team. I feel like the team of teams analogies amongst these groups of people is pretty clear. You have a number of different development teams, say, working towards porting on a particular platform maybe, and the infrastructure team is helping to facilitate that porting effort, while the package development teams of different kinds are working towards that goal. I feel personally like that's a fairly clear instance of team of teams coming through. I want to also consider, though, other levels of teaming within the Trilinos project. If you have a team that's supporting a new platform and getting Trilinos onto that, are there team of teams opportunities perhaps here where these teams can work together with a high level of communication towards a common goal of getting Trilinos ported on that platform? You have the E4S and xSDK teams where you might be working towards common objectives again. You also have situations where you have those user developers that I was talking about, where you have a common goal to support a particular application, and you have those teams working together in that context as well. And then also the SPAC team, which is related to many of these projects in ECP. So if we go to the next slide, please. There are some real teaming challenges here. There are some broad common goals. We want to get onto this platform, or we want to support some particular application. But because there are many funding sources and the priorities are not always equal, teaming can be challenging at times. Maybe something is important, but it's not essentially important enough to devote particular resources for one team, and that's blocking another team. And so there are those challenges, especially with the different funding sources. It's a little different situation than what Todd described with PETSc, I would argue, in that it's not as much, in my experience, driven at the individual level. It is more driven at the small team level, maybe a particular package development team, and it's primarily driven there. And there are funded efforts in those different areas that are directed towards Trilinos, but there's still a lot of challenges in teaming between those groups, and in particular where there's boundaries between teams. There's something essentially that the Trilinos project, in air quotes, should be doing, but maybe that responsibility doesn't fall squarely on any particular team within Trilinos, and so those are challenging situations. How does that collaboration take place? How does a team form in that space or take over that space? And then there's also the challenge that with all of the communication that is necessary, all the different teams that are involved, that people can get really bogged down in communication at different times, or they can have insufficient communication to prevent redundancy in efforts. So there's this balance that has to be struck in communication between different groups. Next slide, please.
Quick 2-minute warning for you, Jim.
Perfect. Thanks, Miranda. We've certainly tried to address a lot of these challenges over the years. The leadership structure has evolved multiple times to try to support these development efforts. Identifying and more clearly articulating and documenting the roles between the boundaries of these teams can help people to understand and set better, clearer expectations. Improving the planning process when you start talking about, well, this team needs this input from this other team in order to accomplish this goal, trying to get that out there, trying to communicate that when it's known so that resources and time can be planned. These are some challenges, but I'm hoping that involving additional team of teams approaches might be able to help us further make improvements here. So I believe that was
All right,
my last slide.
Yeah,
So we
thank
can
you very
move
much,
to the next
Jim.
segment.
So here's the commentary on Trilinos. I think it's great that you've taken an opportunity to contrast PETSc and Trilinos right at the outset. So, Todd did a great job talking about cultivating PETSc like a gardener. And then what I'd like to focus on with the Trilinos commentary is this idea of shared consciousness. And so what I find it particularly interesting about this particular case is that Trilinos is a very mature project. It's been around, as Jim said, for 20 years. And so that does present some communication challenges that maybe other teams may not be experiencing right now, but they might experience in the future. So there's a lot that we can learn from Trilinos and about growth and about what it means to be able to sustain that persistent communication, software as a more persistent form of communication. And so here, this is an example where the software is really the means of collaboration. And also, when we think about how does Trilinos maintain this idea of shared consciousness? And so this shared consciousness, this idea that they have to be able to have and maintain common goals. Jim mentioned transparency. So transparency in this situation being particularly important, not only to those codes and communications that are happening right now, but those that also happened in history, right? And Jim also brought out the communication challenges that Trilinos as a team of teams has because of the numbers of teams and the different types of communication technology that might be a communication technology of choice by a particular team and not another. And so this is really an opportunity, as we have understood in the pandemic, actually, to think about ways that we might utilize these tools as ways of maintaining a type of cohesion, at least with respect to the communication. And as Jim also alluded, the meetings are project dependent, the cadence, how we go about communicating our goals is something that is dependent on the project. But this is also part of the challenges that we will find as teams of teams become more mature and as they grow and have larger communities, larger user groups, and have code bases that are around for generations. So thank you for that. And with that, we can go move on to the next discussion, which, Ulrika, I believe that is going to be you. So I'm going to go ahead and stop sharing my screen.
Okay, thank you.
You're welcome.
I will share the screen. see. All right, so let me go into PowerPoint mode. Let's see. Okay, so do you see this slide?
Yes.
Yes.
Okay, good. Okay, so let me get started. So yeah, so I'm going to talk about the xSDK, which stands for Extreme Scale Scientific Software Development Kit. And I should say that a lot of the things I'm talking about is actually based on a paper I was written by 5 xSDK members. I probably should have mentioned them here. Cody Balos, Piotr Lustek, Jim Ellenbring, Sarah Osborne, and myself. So, okay. So here, let me just talk about the xSDK project itself as a team of teams. So that does actually have 5 different sub-projects. So the original one, of course, was the xSDK product, and I will talk more about this on the next slides. But I do want to mention the other teams also, because they have been added in again later on during the ECP. And the reason why they're here is because all of this is actually about math libraries, and they are essentially were added to improve the math libraries in different ways, be it adding mixed precision, adding batched kernels to it, etc., to get better performance, improving the software quality, etc. So all of these are different part of the xSDK project, and some of these sub-projects overlap. So of course, we do want to talk about mostly about the original xSDK, which is the start of the xSDK project. And that is a team of teams in itself, because of the xSDK is actually a conglomeration of different math libraries. And we are really trying to make sure that they all work well together. And that actually effort already started before the ECP, actually in the Ideas project. So here, the original xSDK vision is really to provide infrastructure and interoperability for all these different independently developed math libraries in support of ECP applications. Here are some examples of different ECP teams who use several of these math libraries in combination. And so it is really important for them that they work well together. So there are 2 aspects. For once, we want to make sure those libraries build well together, and then of course they do interoperate with each other to a higher extent than usually a lot of other software packages too. Down here you see an example. That's actually the graph which shows you the interoperabilities of the most recent xSDK release, which was in November, and all the green dots are math libraries, and then you can see the connections, but underneath they have additional libraries they depend on, which are not immediately part of the xSDK, but all this needs to work well together. So you can see that's really difficult. So the current amount of math libraries included are 24. And I've just added the different logos because I wanted to show how different these different teams actually are. You can see from the designs, they look quite different. Some of them don't have a logo, but so on. So they're really very independent. Most of these libraries already existed before the xSDK. And so they have long-standing development strategies, etc., that do not match necessarily. So that is one definite challenge we have to work with. So that causes a lot of technical challenges. And so the way we did deal with that was we developed a bunch of different xSDK community policies that we actually continue to change when necessary. So here's a website where you can actually find them. And we do like input. So if any of you look at it, you find like there need to be changes, etc. Yes, we do like this. These are not dead, like these are things that are living and they should be changed when needed as software development continues. So currently we do have 16 mandatory xSDK policies, and they're all about topics like configuring, testing, portability. They need to be open source libraries. We want to make sure there are no namespace issue, etc. We also do have 8 recommended policies, and they're about public repository access, error handling, etc., documentation quality. And so they are not required, at least yet. Maybe we will require them later on. And anybody who wants to be an xSDK member package, they need to be compatible with these community policies, but they also need to have an interoperability with another package in the xSDK, and that connection needs to be tested. So interoperability is really important. So we do have, of course, this provides a lot of technical challenges. One of the things is we do have actually regular annual releases, and they require a lot of testing. We want to make sure that all these codes work well on the key platforms and use all kinds of different compilers. And so one of the things is because we only have annual releases, however, SPAC, as our build manager, has much more often releases. And then of course the individual xSDK libraries have scheduled releases at different times. So things are continually changing. And then of course, there are also the lower dependencies to say that can cause additional problems. And so that's one thing which makes it difficult. Whenever we have a new release, we have to make sure this works. But what we really would like to see is that we could continually work on this, right? So one thing I should mention is while all the xSDK libraries are also part of E4S, E4S has quarterly releases actually, but their releases are different because their interoperability is at a very different degree from ours. They do not deal with the type of interoperabilities xSDK deals with. So, but I should say that our releases do help them in some ways. So one thing we really would like to have, we want to have an effective continuous integration testing. And as I said before, we need to do a lot of testing for every release. Because we run on different platforms, different compilers, etc. On top of it, we have the issue that not all xSDK library developers are funded under the xSDK project. This portion is a little bit different from the other 4 sub-projects I showed you, which were all funded under ECP, because we are relying on a lot of different libraries that have a lot of different developers, and they're not necessarily funded. So we usually have a contact person for some of the project, not even all of them. We have some libraries included that are not funded at all by ECP or even DOE, or some of them are outside the country even so. And so that makes it more difficult. If something breaks, we need to rely on them voluntarily helping us. One thing we would like to really have is an automated process that would allow us continually test throughout the year using development versions. That's of course that's probably not achievable to that extent, but we certainly can make progress towards that. One thing we have done, we have started to use some GitLab runners where we just test subsets of the xSDK that use development versions. And that has actually been helpful to find some problems early on and fix them before they turn into real issues for our users. So since this is a very challenging issue, we do welcome any input on solutions to these challenges. So if anybody here who has ideas, please come to us. We love to hear about it. So I do want to also talk about the cultural challenges there are. As I said before, this larger xSDK project is actually very large. There are 50 or more, probably 70 by now members, as we have added more sub-projects. We are spread out over 6 countries, 6 time zones, which of course that causes some issues. One of the things that does help, we do have regular virtual meetings at a time which is sort of historic time more or less. And so people are generally able to attend because they know about this. If we have more important issues, like when we have a new release, we also take a lot of advantage of Slack or GitHub pull requests, etc. And we do have a lot of different people. So there's a lot of differences in language, communication, and personalities. And so this requires us to learn to communicate with each other, which of course is a lot harder to do virtually. So one of the things we have done in the past that didn't really work well during the pandemic is trying to use any opportunity, be it the annual meeting right now was a good one, for example, or conferences, large conferences where we have a lot of our team together to try to meet and have dinners, etc., to make this more personal. Of course, the other thing that's important, we do have regular milestones that have a deadline, and that already forces collaboration, which also helps to bridge communication issues. If there's a need, you work it out. So additional challenges, of course, is if you have such a large team, you want to make sure to keep it motivated. And so one thing, of course, is we do want to have a challenging, inspiring goal. Well, Exascale certainly is that. But of course, there are times when this can get overwhelming because that's a huge goal. And so it is really helpful to have these smaller tasks or milestones that help us to get some satisfaction in between. We got accomplished with something, we can move on. And so, and of course, another thing that's helpful, which I'm sure we can do more of, is to acknowledge contributions of individual team members to keep them motivated and happy. So. And to end this on a happy note, I do want to talk about the opportunities that we also have because our team is highly diverse. So we do have many differences in age, gender, race, nationality. There are lots of different life experiences, technical skills, etc., work cultures. And that really helps for people to have very different perspectives and think differently. And so that it really helps to get faster, more efficient solutions. So we always have somebody who has some idea who can do something. Of course, also when you have a larger team, you do have connections to other experts that can really help to get more input for difficult problems, and you have more people to reach out to, which is great. Of course, the ECP itself is really great with regard to that. The collaboration here and the accessibility of a lot of different experts is really great and helpful. And finally, I just do want to say that different personalities are also helpful. Like, for example, if you get stuck, if you have a person with a positive mindset that can help you to think more positively, that's great. If you have somebody who can tell jokes, if you can laugh, that's great too. People who can think outside of the box, all of this is really helpful to move forward. And so that's what I have to say so far. So, and so I guess we can move on to the commentary. Let me stop sharing.
Thank you. Fantastic. So Ben, I believe you wanted to share your screen.
Yeah, here we go. Okay, hopefully everyone's seeing that.
Yes,
and hearing
sir.
Me.
Mhm.
All right. So thanks, Ulrika, for a really interesting talk. And one of the things that all these talks made me think about is this concept I've been reading about called governance. And I think governance is a really interesting and kind of important underlying concern in Team of Teams for various reasons. So the definition of governance, this is from an open source software context, is how do you achieve the direction, control, and coordination of a bunch of autonomous individuals or organizations that are all contributing to a software development project jointly. And so that this definition, I think, actually really fits very well with Team of Teams, because it emphasizes that, it's not, this top-down kind of system. These teams are always kind of distributed. And so some of the things, there's a list on that second bullet there of, some of the things that might come up under governance having to do with, licensing, roles and responsibility, credit and citations, even down into APIs and different ways that packages are supposed to interact with each other, things like that. It gets into the technical aspects as well. And if you have a kind of a small focused team, a lot of times you can handle these issues through kind of informal standards and norms. But it might require more effort at a Team of Teams level. And Team of Teams also create these challenges because of the way they're kind of that distributed and loose structure that we've been talking about. So that's a question of how do you keep it a coherent project without compromising the autonomy of the individual teams too much. Some of the Team of Teams literature comes from a military kind of context, and they talk a lot about how, battlefield commanders need discretion to make on-the-spot decisions. You can't run it all through a central board or something like that. And there's this idea of temporal rhythm where you kind of like decide, you give autonomy to people at the local level to make quick turnaround decisions, and the bigger decisions get made much more sort of slowly by larger kind of governance bodies. And so I think that came up kind of in the background of all these talks, but I had kind of a question for Ulrika, which is, so how do you do that on xSDK? How do you strike that right balance between having strong enough policies to keep the project on track and allowing individual teams the leeway to do things the way that works best for them? And has that changed at all over the course of the project?
So, of course, as far as the actual policies is concerned and making sure that we are compatible with this one, they're pretty clear, those rules, but we're trying to keep them at a stage that they're not too binding towards the different software teams, right? So they don't have to worry about changing their strategies of how they develop their codes, etc. But other than that, I kind of consider the project more like a democracy, I hope. I really want people to all be able to have input to talk, and we can discuss things and decide together how we're going to do things. So whenever we have milestones, we do determine that together, for example. But ultimately, if I don't get input, then I do have to make a decision as a leader of the team, of course, right? So.
All right, thanks. So that's my commentary and my questions. So I think we can move on to the next.
Okay, great.
And
Thank you,
stop
Ben.
sharing here. All right.
I'll go ahead and share my screen now. All right. So Jim, take it away.
All right, thanks, Elaine. So I'll be talking about E4S also. If you're not familiar with E4S, it's an ecosystem for HPC software. It consists of many different products, most of which are part of ECP software technologies, and they span a wide variety of areas, includes the projects from the xSDK. It includes data and visualization software, includes a wide variety of software technologies, software programming models and runtimes, development tools, workflows, all of that software from software technologies. E4S is up to 100 full release products as of its latest release. There's been an impressive string of releases throughout the last few years here. And that is quite a effort in coordination. So if you want to go to the next slide, please. You may have seen this slide before about what E4S is and what it is not. I want to stress here that E4S is not a very specific monolithic take it or leave it chunk of software where you are getting a huge piece of software. Think of it more like Linux, where you can install different sets of packages. You can install different things that you want. You don't have to install other things. It's not a perfect analogy, but it is a pretty good analogy for what E4S is. If you have more questions about E4S later, I can take those, but I'd like to move to the next slide for now. So what is the effort behind E4S? Who are these different teams? There is a core team of people who think of themselves as working on E4S. This is a handful of people. These are people who get the releases out there. They test the releases. They try to install E4S as a whole on different platforms. It's a relatively small group. Then you have all of the individual products that make up E4S. Looking back on this session, you have Trilinos and PETSc as a couple of those. And there's the other 20 some members of the xSDK, and then lots of different software technologies, primarily software beyond that. This is about 100 teams. Some of them are very, very small. Some of them are very large. Then you have also these SDK level teams, the xSDK Ulrike just talked about, but there are teams of varying levels of formality. The ExaWorks workflows team is a little bit more formal than some. The development tools team is a little bit smaller and informal, but they're mostly small. Then you also have the teams at the various facilities that work on deploying E4S in conjunction with the core E4S team. Those are very important to E4S as a whole, and then the SPAC team, because SPAC is related to all of this. SPAC is the deployment vehicle for E4S. So if you want to advance to the next slide, please. E4S, again, has a unifying goal. Here I tried to summarize that with some verbiage from the website. It's a community effort to provide open source software packages for developing, deploying, and running scientific software applications on high performance computing platforms. That's pretty broad, right? So within all of these different teams, that is kind of a general goal, but they all have much more specific goals. And so, this goal in a sense unifies people, but it's so broad that I think there's some challenges there again in prioritization. And then if you look at these teams that I talked about on the last slide, from the individual product teams to the core E4S teams and all the others, there's various different elements of the project that each of them are engaged in. And you'll see a lot of overlap here. And I don't want to go through all of these specifically. I think that'll take too long. But the point that I want to make here is that there are some opportunities here. You see that the E4S product teams, for example, they're involved in testing. And you know what? All of these other teams are also involved in testing, but they don't test the same things. The core E4S team testing is primarily installing software on a platform. The individual product teams are testing to make sure that their products work on the platforms, but they're probably running more tests than the core E4S team that might just run some smoke test teams. The SDK teams are looking to port their SDKs in some instances. The facilities teams are trying to deploy this software and trying to run some mostly smoke test level things again to make sure that things work. And so the point being here, all of these teams are testing. They're using a little bit of a different strategy. They have a little bit different objectives, but each of these testing efforts, if done properly, can inform some of the other efforts here. So the individual product teams, if they do some testing and they find out the best way to run things and they keep things running, that can inform the core E4S team about how to best include that, and the facilities team the best way to deploy their software. The product team effort also keeps that product working, which makes the core E4S team and facilities teams jobs easier. These are just a few examples, but the challenge there again is, how do we facilitate the movement of that information? So if we go to the next slide, this communication that's necessary between these different teams is again key here. But again, there's not enough bandwidth to be part of every communication. So we need to communicate. What's a good way to communicate in this context? I feel like one way that has shown a lot of promise is communicating through workflows. So if one team, for example, the product team, finds that the way to build their software on a particular platform is using some set of options, or that some option doesn't work on a platform, that can be communicated by having their workflow, including the process of noting that in SPAC, for instance. And so then the SDK team and the E4S team, the facilities team, pick these things up naturally as part of their workflow. That becomes the default on that platform. We're not reinventing the wheel. What about in the other direction? You have the facilities staff working to figure out how to build software on a new platform in general. They might have some tricks of the trade for building on that platform. If this is communicated through workflows and put into, say, a SPAC recipe or SPAC environment where it can be shared, then that can facilitate faster porting efforts by each of the individual product teams. And so some of this communication doesn't have to be, mouth to mouth, leaving, where is your documentation for this? If we can work it into the workflow itself, I think that is a very important strategy to consider. So that was my comments on E4S or overview of E4S. I think we can move to the commentary.
Thank you very much. Go ahead, Greg, sorry.
That's okay. Yeah, thanks, Jim. So, I mean, it's pretty clear from Jim's description that E4S is it's a group of projects all working together towards some kind of common goal. But what I wanted to do was drill a little bit more into the definitions of a team of team and see how it kind of stacks up to, to those definitions and how effectively it's working as a team of teams. So the first one is a team of teams essentially is a cross-cutting hybrid form of organisation. And E4S, you know, its stated goal is to provide this ecosystem of open source products, and you know, and integrate those products together and deliver those products. The products themselves are very specific things, although interestingly, E4S is really even a multi-level hierarchy, because some of the projects and groups within E4S are themselves groupings and teams of teams, as we've seen, for example, the xSDK. But I think it's pretty clear that that E4S provides this cross-cutting kind of organisation where it's trying to tie together a very disparate group of different types of projects. So I think it fits into that category pretty well. The second is that if you've got multiple teams that have their own distinct identities and goals, that they share one or more overarching objectives with other teams. And the key here is that then leads them to find ways to work together effectively. And we've seen from Jim's description that, you know, there's a wide variety of teams that have very distinct identities and goals. In fact, he even gave them different names, like the core team and SDK teams and so forth. So the naming, you know, implies that they're doing very different things. So, you know, so that aspect is, I think, is pretty obvious. The thing that really ties them together, in my view, is these overarching goals that they've defined in order to ensure that their releases are high quality. And the SDK, the xSDK project has some of these as well, but at the higher level in E4S, they've also got a set of you know, clearly defined policies that are aimed to lead towards that outcome. And so I think that is something that helps those teams try and find ways of working together more effectively. And the teams themselves need to work on, you know, as Jim pointed out, there's this and these different activities such as porting and packaging and so forth, and what they actually mean for the different projects can be different. Testing can mean a different thing for one project versus another, but they're very related activities, and they feed into these overarching goals. So I think that, again, E4S meets this criteria very, very strongly. And then the third one is really, you know, how you maintain this awareness and the alignment of the goals. And this is really the thing that's key to the success of Team of Teams. And E4S does this by having a very clearly defined set of community policies that relate to how you become a member of E4S. So in order to become a member, you have to meet certain criteria, and then they have various levels of membership and clearly achieving those levels of membership. So just that in itself, I would think, is something that people are thinking about as they're working and they're contributing to the E4S. And so that's maintaining that mutual awareness of what it is, what the important aspects of the E4S project are. And then in addition to that, there's a lot of communication channels that are also provided by E4S, such as BOFs and tutorials and so forth, and webinars, which again I think is pretty key to making sure that everybody's aligned and aware of how the project wants to move forward, what new policies perhaps make sense to adopt, and essentially keep moving the project towards a successful conclusion. So if we go to the next slide, which really just is the stamp of Team of Teams, but I think it's a it's a pretty good indication that E4S meets these criteria, and even has some more interesting characteristics in that it's an even higher, it's a more hierarchical, where you have teams of teams of teams in some sense, but definitely meets these criteria. So that's my commentary.
Thank you very much, Greg. All right, so this has been our tour of some of the ECP projects that we believe exhibit some of the characteristics of teams of teams. And in particular, I think one of the key takeaways for me is that actually, if you think about your own project or the projects that you're part of, one thing to consider is, when do you become a team of teams? Maybe you are part of a team of teams right now. If think about your projects outside of ECP, I guess we're arguing that if you're part of the ECP program, then you are part of a team of teams. But if you think about just how teams form and when they might become parts of teams, I mean, it happens very quickly, because it's not just our small team or the individuals in the team, but it's also the ways that these teams network and connect with other teams. So as your codes and your software, as you acquire more users, or as your code touches other code, then the likelihood that you're part of a team of teams grows. And so, we heard from different speakers where we talked about cultivating an ecosystem like a gardener. In other words, thinking about that entire ecosystem instead of just the moving parts. We also heard about mature projects and some of the communication challenges over time. We also talked about different cultures and different governance models for teams of teams. And then finally, this idea that has been sprinkled throughout all the talks is the role of liaisons, or people that are part of different teams, and what they bring to each of the teams that they're part of, and how that can be really leveraged to really just build this robust culture throughout the network. And so now is actually our time for audience Q&A. So I'm hoping that you've had an opportunity to think a little bit about the presentations and to consider some questions that you may have for us. So I'll go ahead and stop sharing my screen. I haven't been able to see the chat. Are there any questions? Does anyone have any questions? If you'd like to unmute and ask, or you're welcome to post it in the chat.
So I would just have a follow-up to your comments, Elaine, about noticing about, when do you become a team of teams? I think it's not about when do you become a team of teams, but when do you realize that you already are a team of teams?
Right.
So I think it's sort of that. I think that's where it is when do you realize that?
Right. That's a good point. So do you want to say a little bit more about that? Because I think there is, you mentioned awareness. And so there are certain cues that probably you can identify that to you have cued you as to when you've become a team of teams, or yeah.
Well, I think that it's any project of a sufficient size is naturally just a team of teams to begin with. And then whether you realize it or not, you're still adopting some of those principles sort of naturally. And so the sooner that you realize that, you really are a team of teams, you may be able to accelerate, those practices, the good practices that you really do want to adopt.
Great, thank you. And so, David, do you want to just unmute and ask your question to the group?
Sure, maybe that's easier than you reading what I typed. So, yeah, so I'm curious what the panelists or speakers' thoughts are on how much it relies on kind of central funding. The team of teams efforts I've been part of seem to always work well when there's a funded organization that seems to kind of manage the network.
So I think, Oh, go ahead, Ulrike.
Yeah, so obviously we do need funding. So I think it is important that we do get follow-on funding. Even so, I do mention there are various people in our team of teams for the xSDK, for example, who are not funded by ECP, but they do have funding elsewhere, right? So I think that is really important in order to make sure this can be sustained. So
I was going to say that I think consistent funding or common funding for the entire group sort of gives you a pretty big hammer to use with the group to sort of enforce these things. And if you don't have that, then you have to adopt other strategies because then it really becomes more of a community effort. And so you have to do more community development and make sure you're bringing people along with you and that they all share the vision rather than, looking at just the funding stream. So funding is important. And I would say that, yeah, most people and everybody in PETSc is funded at some level, just not from DOE. But
Yeah,
we
I
have
was
to
wondering
go
more
and do
about
those community engagement activities because we don't have a centralized funding model.
Yeah, I was thinking, especially for the funding of the people who kind of feel like they're in, managing the network. That seems to be sometimes what falls apart. Even if the funding is good, if there's nobody who feels they're funded to be the gardener.
Yeah, so for PETSc, it really is, there's the leadership inside of PETSc is funded out of different buckets of money. And not all of them are at a single lab. So Barry Smith is now at the Flatiron Institute. So he still maintains a leadership role. We have Jed Brown and Matt Nepley are at universities who are also key elements of the leadership team. And then I'm at the laboratory and I manage the lab side of the project at Argonne.
Yeah.
So
I think
it's still distributed leadership there.
yeah, it's similar for the xSDK. Sorry, Jim, go ahead.
You can go ahead and finish, Ulrike. That's fine.
Yeah, I was just saying it's similar for the xSDK because we are distributed all across. And so the key people are at different institutions. And right now they are funded under ECP. So the question then is what's going to happen down the road, right?
Yeah,
so we'll find out. So, but yeah, I think it is important to have those because people have to eat, right?
So I think it's very important to have common funding as well, but I will point out a couple of things. One is that I think having common funding for the whole project can be a disadvantage in two different ways. One is that you potentially become very highly dependent on that one funding source, and that can be a sustainability risk, and it can also put blinders on which things should be what you should go after, and maybe it's not always the best choices. And I think also kind of paired to that is that you necessarily have to build a more inviting community if you don't have that. You can do more draconian, awkward things and people will tolerate it because they have to. If you have one, kind of common funding source, it has to be more inviting as a community. And over time, I think that has more impact. I think early on in a project, that's less impactful, but as time goes on, that becomes a bigger factor.
Yeah, just to follow up on that before we move on to another question, I really agree that the benefit, I guess, if you want to say there's a benefit, the benefit to not having one common funding source is that you are in some respects incentivized to be more creative with the way that you develop community, foster community, and really maintain culture. And so there's a lot that we can learn from that. And also, I just want to say that when we talk about team of teams and governing or being part of the model of leading a team of teams, we can lead from different points in the organization. So it doesn't necessarily have to be a leadership that is hierarchical. Leadership can exist from within the team. And so these teams can take ownership and leadership for the way that they cultivate their own shared consciousness with the other teams around them. And David, I think you had a comment. Did you want to comment on this question or a different question?
It's actually kind of a follow-up to this discussion, and maybe a lead into a question on shared goals and visions.
Okay, great, thanks. Well, go ahead if you're going to follow up on this. Go ahead.
Okay, so I see a lot of discussions on funding that, like, we'll start talking about a topic and we'll realize that things are pretty good, and we'll attribute it to the funding model, and then we'll say, can we make things continue to be good because our funding model is, to make our funding model continue to be good. And I really want to contrast my experience in academia versus my experience in DOE. A lot of the things that the way that I've been a part of teams in the DOE has been on larger teams that are connected to lab visions and missions, and have discussions about what are our shared goals. And I think maybe it's not so much the funding model. Okay, so the shared goals and visions, I think, are more important than the way that the funding is handed down. But there's a connection in that in traditional academic labs, if funding goes to one PI, there's a disincentive to make a shared goal. There's an incentive to have a goal that is specific to my lab and exclusive of all the others. So there's a connection between the funding model and the shared goals, but I think that having those kind of shared goals, or even creating an organizational structure absent a funding model that has those shared goals, will make the funding model happen.
Thank you. Ben, did you have a comment about this question?
Yeah, I just had a quick comment. I mean, I guess in computing, I think we often think about team of teams as being an alternative to like not having a team of teams, but sometimes the alternative is a really rigid hierarchical structure, kind of top-down hierarchy. And those things, if they lose funding at the top level, the sub teams and sub organizations in the tree haven't been talking to each other or interacting like a team of teams does, the whole thing can just blow up. At least team of teams probably does work better if there's sort of a common source of funding, but it has this sort of built-in resilience as well.
Yeah, that's a nice comment. Greg, did you want to follow up on this topic?
I just wanted to just briefly mention open source community. In the communities that I've been involved in, they've all had some kind of centralized organization to really, it comes down to the communication and the policies and the governance and all those issues. You really need to have that in place. And there has to be some kind of funding for that. And I think that's what David was originally alluding to. I don't know of any effective, big, large open source organization that doesn't have some kind of model like that in place. But in many of those, the teams themselves are very self-contained. They might be like a team in a vendor, that's working on a piece of software that then gets contributed to that open source community. And so the funding of that centralized body is an interesting kind of exercise in its own right. And there's obviously lots of different ways that you could achieve that. But I think that, in order to look at the sustainability of some of the projects coming out of ECP, it would behove us to look at, how those open source organizations have achieved their sustainability. Because some of them, like the Linux Foundation and so forth, are incredibly well established. And so I think there's a lot we could learn from those.
I think that your comment and Ben's comment really leads us into Scott's question. So Scott, would you like to unmute yourself and ask your question? Thank you.
Yeah, sure. I was just asking, is there a way the team of teams model can be perpetuated in other projects and programs post ECP? Because I was, pointing out that I think it's such a great and robust dynamic. Just watching all of this, I was just seeing how everybody works together so so nicely and builds upon one another's strengths. And so I guess I can see certainly sorry, my phone is ringing. I can certainly see how funding is of great concern. But then I guess I wasn't even thinking in that way. I was thinking more along the lines of philosophy and methodology, maybe superseding that somehow, with if it's really laid out well in our environment. I mean, the book's great. Stanley McChrystal's book is great. But I was thinking like in our environment, if somebody really laid out a way to make it happen from the philosophical standpoint, looking beyond funding, if that makes sense,
That's a great question. I think Todd may have an answer for you.
Okay.
Well, I have part of an answer for you.
Yeah.
I would start off by saying that prior to ECP, and even though we weren't using the words, we were still a team of teams before ECP, and will continue to be a team of teams after ECP, independent of whether we use the formalism or the words. So I think the methodology is there. It was there in the beginning, prior to ECP, and it will continue afterwards. It may become even more embedded, and we may do more things now that we've had this incentive to really embrace it even more during ECP, but I don't see it going away.
Okay.
I think in the case of ECP, the common funding and the common drivers that Todd was kind of alluding to in bringing people together more, I think that was somewhat transformational for a lot of teams. This co-opetition concept is moved more in the direction of cooperation, I think, than what it previously had been, at least in my experience.
Oh, nice.
Yeah, I agree with that. I was thinking that having this overarching goal is really important for that. I was thinking about other efforts within DOE, like, for example, like the SIDAC, right? You have a FastMed Institute, you have applications and partnerships. They're supposed to all work together. But I think, so you do have different teams within one big institute or so. But I think what was sort of missing there is just this overall push. You have to get to Exascale. You have to do this, right? And yes, of course, there are teams still working together in this context, right? But what is it about ECP that made this much bigger kind of collaboration actually happening? And I think it's really, we were all moving towards this goal, Exascale. We want to make sure things work well. And it's such a huge undertaking. And yes, we did get a lot of funding to do that, right? So I think having that common goal is really important.
Yeah, common mission, goal.
And then just a last comment about this, I would argue too, Scott, that awareness and communicating what constitutes teams of teams to all of us 1,000 researchers helps propagate the model and helps us all become more aware of our individual, responsibilities in the community or opportunities, to continue to be teams of teams, after ECP.
Yeah, I like what you said, propagating the model. I guess that was kind of the spirit behind my question. It's like propagating the model in a way that makes it really, really take hold everywhere. If that
Right.
makes sense.
That's part of the idea of empowered execution. So being able to, for lack of a better word, empower everybody to be able to understand, hey, this is how I would identify the context within with which my team works, and these are the characteristics, and these are the capabilities I have that I can use to continue to foster this culture. And so, yeah.
Okay.
Sorry, what were you going to say?
No, I just said well said. What that last part of what you said.
Thank you, Scott. Okay, so I think Elsa has a question. Thank you for your question, Scott. That was really great.
Yeah, so my question is for the for in E4S, it really does seem like they're a magnitude larger than these other team of teams. Like you mentioned, it's a team of teams. And how do you engage with that lowest level, or do you have to have some hierarchy here? How do you engage, especially when you want to adapt new policies and maybe push all of the softwares to to adhere to these new policies?
It's slow. But you reach out slowly over time, I think, and try to socialize ideas. And we did multiple rounds of feedback with the policies, for example, and then they became part of the required review process for software technologies in December of last year. And so then anyone who wasn't engaged in the process became naturally engaged in the process at that point. I do worry at times, and I talk about the scalability of the E4S, the small E4S team that I talked about, reaching out to each of those individual products. And that's where some of the discussion has come in lately of, can E4S start using more formally the xSDK SPAC meta package? And so that, that some of the communication can go from the E4S team through the xSDK team down to the individual product teams to try to make things more scalable. That said, there are a lot of issues, individual porting issues and things that do go on at the individual product level. So we're still feeling through some of those things and just trying to be efficient with it. It's a challenge because people see E4S as important, but they have lots of other science goals that might be synergistic with it. So it might not be the highest priority if a particular issue comes through the E4S reporting system or something like that. So you need to take all of that into account when trying to figure out timelines and objectives. So one example of how we maybe handle some of that complexity with having so many teams there is when we do a release of E4S, it's not necessarily required that every single product be deployed on every single platform, right? So if something doesn't work, and with some reasonable amount of effort, it can't be done, it's explicitly turned off in the SPAC environment for that platform in that SPAC recipe. And that can be turned back on. You can, work with the team and get that turned back on. But even just doing that is helpful communication about trying to set expectations for what E4S can do and can't do on a particular platform. So anyway, is that helpful?
Yeah, definitely.
Thank you for your question, Elsa. And thank you, Jim. So we have time for maybe one last question, and it's good because we only have one left, and it's Lori's question. Lori, would you like to unmute and ask your question? Thank you.
Sure. So, it's a very interesting discussion. I want to thank everybody for the presentations and discussion. But Elaine, you started the conversation with the, leading question, ECP is doing a good job, or is it, right? So you started there. So I want to loop back to that and just ask the panel, are there things that come to your mind about what ECP could be doing better, from a team of teams perspective? I've not had the opportunity to read the book, so I don't know all the richness behind Team of Teams. So I'm just wondering about your perspectives on this.
I personally think ECP does a good job at it. So we certainly have more of a hierarchical structure than you would get in a team of teams. But part of that is the nature of the project. But we do get cross-fertilization among the teams, and certainly at the leadership level and in the extended leadership teams, and even sometimes down among the individual projects. So the collaborations between the application teams and the software development teams, I think has gotten better. So I think we're doing a pretty good job inside of ECP at this point.
Okay.
I don't know that I would make any strong recommendations.
I don't feel like most of our challenges with Team of Teams are related to impediments that ECP puts in our face at all. The impediments we have are the existing workflows at existing institutions, kind of trying to break down some of the silos around certain development patterns. ECP encourages shared fate milestones. We have a fair bit of latitude, I feel like, to reach out to collaborators, even, far across, the software technologies people are explicitly encouraged to work with HI, for example. And so I think there's some strong collaborations that go on there. I can't think of anything right off where I would think, oh, this ECP policy is preventing us from being more effective in teams of teams endeavors. Sorry.
No, that's okay.
Yeah, I agree. I agree. I feel like things are going really well. As far as it's a really exciting project to work on, the ECP, and I feel like a lot of things have happened which I haven't really seen to that extent elsewhere before. I'm sure there are things you can do better, but I can't think of any either right now, because I just feel like overall it's been a very positive experience. So
yeah, I mean, if you think about, what are some examples of some things that hadn't gone as we'd hoped in terms of being able to team across different institutions and stuff? One of them that comes up to me is like the federated runner effort, right? Where you have federated GitLab runners.
Yeah.
And we wanted to have that across a bunch of institutions.
And federated logins.
yeah.
Wow, Todd, you're really
I'm really pushing it there, but
take it easy. Okay. But I don't see that ECP is putting barriers in place. I think ECP was trying to facilitate that, and that's some of that stuff, maybe not ever shared logins, but maybe runners and stuff on kind of starting with point-to-point bases or something. Maybe we'll get more of that over time. But I don't see that ECP itself was an impediment in any of those things coming to fruition. So.
Thanks, Jim. Ben, you had a comment?
Yeah, I'm not totally sure about what I'm about to say, because I wasn't around when ECP was kind of put together, and I haven't read all sort of the governing documents, et cetera. But I feel like one of the things is that this team of teams thing has kind of been an emergent thing that kind of came up from ECP because of the way it was structured and because of some of the goals. But I don't think it was ever an explicit sort of goal of the project. And people have been really flexible in adapting to that and getting it, removing barriers and things like that. So right, the only thing I could think of that would be an improvement is to actually sort of explicitly acknowledge it and make it a measure, a goal that we're going to try to measure and make sure that we're achieving.
Yeah, there was, I was going to say, Lori, that as you can see, I think that we've answered the question that I posed in the beginning. I think that we agree that we like where we're at with ECP. But I would also like to take an action, if you don't mind, to get back to you on your question. Give us some time to think about it a little bit more.
Oh yeah, no, I definitely like to hear from you guys. If you've had a few minutes to reflect on the, what could be doing better. And then I take your point about, I think there were aspects that were, in people's minds, from the very beginning about, creating the portfolio of software. Certainly as soon as Mike took over ST, that became a pretty explicit goal from leadership. But yeah, I also agree that from the inception, I don't know that team of teams was discussed as a goal, and therefore were there things we could have built in that would have even helped facilitate it even more? I'm not sure. I think it's an interesting thing to think about.
Yeah, so let us consider that and get back to you and Doug about that.
I would say that the team of teams terminology was not used, but if you think about the initial ideas project and the xSDK effort coming out of that, the software development kit idea, and then eventually E4S built on top of it, was very much based off of the xSDK effort and trying to find the right analog for that across the different focus areas of software technologies. We didn't call it team of teams, but that original ideas effort was breaking down those barriers already and getting those teams to work together. Although we didn't have the vocabulary, I think that concept was very much at the heart of the design of software technologies.
Well, I do think it's also an interesting question that was asked earlier about, what's the future of these approaches once ECP ends? Because there have been many other things like xSDK, previously tried in SIDAC, and the linear solvers interfaces. And, there have been a number of efforts over the years that, if they're not continually built on and funded, they tend to wither. And so how do we prevent that from happening from here? Right.
That's a good point. David, would you like to make a comment? I just want to say we're over, but we are on a break, so we can continue as long.
I do need to run to another meeting. I want to say thank you to everybody. Again, great discussion.
Thank you very much, Lori. David.
Yeah, well, just the feedback on what we could do better is ECP. I mean, I think we work really well with kind of communities that we know. But one of the kind of problems is that if there are people who want to participate who are not maybe plugged in, the team of teams approach is a little bit hard because it's not clear who you go to or how you participate. I mean, I work with industry a lot and they're very interested in picking up code, but they kind of bounce off ECP as far as figuring out who they work with and how they get involved. So
that's a really good point, that a lot of what we are talking about may be really rather implicit. It's not codified, and it's not something that people outside of this community, this organization, this ecosystem can really understand.
Yeah. I mean, even just the fact that a lot of teams use Confluence as a meeting point to store things, but if you're not kind of in a national lab or an ECP member, you don't have access to that. And so even trying to get access for some of our industrial partners to Confluence has not been possible at this point. So.
That's right. Thank you. Does anyone have any last comments that you'd like to make before we end the session? Any last questions or any, I would say, reactions or feedback from anyone who has been listening to us for the past 90 minutes or so?
Elaine, this is Suzanne Peretti-Kuhn from Oak Ridge National Lab. I just wanted to say that I really appreciate this approach that you were talking about. And I would love to see the team of teams thing applied broadly across lots of efforts that the labs and industries do. So thank you very much for this very interesting seminar.
Great. I'm really glad that you've enjoyed it. And I hope that everyone else has too. And I really want to thank all of the speakers today and this incredible team of folks, not just these folks that are here, but the entire ECP team. I think that as you can see, we're all really excited to be here, and this is a very exciting project. So thanks for the opportunity. I hope you have a great rest of the annual meeting, and thank you very, very much for coming and for your participation.
Thank you.
Thanks, everyone.